Hello students. Hello and welcome to this video. In this video, we will solve question number 51 to 60 of binomial theorems. And the link to download the PDF will be in description. I will show at the end how you can download and maintain an updated copy of the PDF. Also, I'll show you my website at the end where you can come and ask questions related to class 12 mathematics. So without further ado, let's get started. Question 51 says that show that if the greatest term in the expansion of 1 plus x to the power 2n has also the greatest coefficient, x lies between n upon n plus 1 and n plus 1 upon n. So the middle terms have the greatest coefficient, therefore the middle term in this case would be n plus 1th term will have the greatest coefficient. So Tn is equal to 2ncn minus 1 x raised to the power n minus 1. Tn plus 1 is equal to 2ncn x raised to the power n. Tn plus 2 is equal to 2ncn plus 1 x raised to the power n plus 1. Now we are given that the greatest term is also having the greatest coefficient, that is Tn plus 1 will be greatest. So we divide it by Tn plus 2, we get n plus 1 upon n into 1 upon x. Now since Tn plus 1 is the greatest term, Tn plus 1 upon Tn plus 2 would be greater than 1. That means x is less than n plus 1. Similarly, you consider Tn upon Tn plus 1 and you let that be less than 1, then you will get x greater than n upon n plus 1, and thus we get the two limits for x. Question 52 says that find the greatest term in the expansions of the first expansion is 2 plus 9 upon 5 to the power 10. So sixth term is the middle term, which will be greatest. So T6 is equal to 10c5 to raised to the power 5, 9 upon 5 whole to the power 5. That is 10c5, 18 upon 5, raised to the power 5. Second expansion is 4 minus 2 to the power 7. We let TR to be the greatest term, then TR upon TR plus 1 greater than 1 and TR upon TR minus 1 greater than 1. Substituting the value, we find that R is equal to 3. So T3 is 7C2, 4 raised to the power 5, 2 square, that is 86,016. The third expansion is 5 plus 2 raised to the power 13. So again, we left TR to be the greatest term. TR upon TR plus 1 will be greater than 1. TR upon TR minus 1 will be greater than 1. We substitute and evaluate, you'll find R is equal to 4. So T4 is 13. This should be 10. 10C3, 5 raised to the power 10, 2 raised to the power 3. It looks like the power is 13 here. So this should be 13. Okay, there is a mistake here. This should be 13. This is fine. T4 is fine. This should be 13. Question 53 says that find the limits between which x must lie in order that the greatest term in the expansion 1 plus x to the power 30 may have the greatest coefficient. So the greatest coefficient is the middle term. So 16th term will have the greatest coefficient. Now T15 is 30, C14, x to the power 14. So if you look at this question 53, it would be similar to 51, right? So instead of 2n, we have 30. So the answer would be similar, n upon n plus 1 and n plus 1 upon n. That is 16 upon 15 and 15 upon 16. That is the limit. You solve it and you will arrive at this answer only. Question 54 says that if n is in the set of positive integers, then prove that 6 raised to the power 2n minus 35 and minus 1 is divisible by 1225. So we are given that 6 raised to the power 2n minus 35 and minus 1 is equal to, we get rid of 2, we get 36 to the power n minus 35 and minus 1, which is equal to 1 plus 35 to the power n minus 35 and minus 1, which is equal to 35 square times NC2. We expand this and you cancel the first two terms plus 35 NC3 and so on. So it is 35 square, which is 1225. So the whole thing is 1225 into positive integer if n is greater than or equal to 2. If n is equal to 1, given expression becomes 0. Hence, for all positive integral values of n, this expression is divisible by 1225. Question 55 says that show that 2 raised to the power 4 and minus 2 to the power n times 7n plus 1 is some multiple of the square of 14 where n is in the set of positive integers. So we take the power out n, and so it becomes 16 to the power n minus 2 to the power n 7n plus 1. And we split this into plus 14 to the power n minus 2 to the power n 7n plus 1. So you get 14 square times MC2 into 2 to the power n minus 2 plus MC3 to the power n minus 3 into 14 up to 14 to the power n minus 2, which is divisible by 196 for all positive values of n. If n is equal to 1, the given expression becomes 0, which is also divisible by 196. And 196 is the square of 4. Question 56 says that show that 3 raised to the power 4n plus 1 minus 16n plus 3 is divisible by 256 if n is in the set of positive integers. So what we do here is we take 3 out, we get 3 to the power 4n minus 1 plus 16n. That is 3 times 81 to the power n minus 1 plus 16n. We split it, we make it 1 plus 80 to the power n minus 1 plus 16n. So what we get is 3 times 80n plus NC2 80 square plus NC3 80 cube up to 80 to the power n. So what we get is 256 times n plus 75 NC2 NC3 times 80 up to 80 to the power n minus 2, which is divisible by 256 for all n. Let me think a bit carefully here. So this would be 80n plus 16, 96. Okay. 240 plus 16, 256. That is fine. All is good. Question 57 says that if n is in the set of positive numbers, so that 4 to the power n minus 3 and minus 1 is divisible by 9. So similarly, we expand 4 to the power n as 1 plus 3 to the power n. We get NC2 3 square plus NC3 3 cube up to 3 to the power n, which is divisible by 9 if n is greater than or equal to 2. If n is equal to 1, the expression becomes 0. And hence divisible by 9. Thus given expression is divisible by 9 for all n in set of positive integers. Then we have 2 to the power 5n minus 31n minus 1 divisible by 962. So we make it 32 to the power 5 is 32. We make it 1 plus 31 to the power n minus 31n minus 1. This will be NC2 and 31 square plus NC3 31 cube up to 31 to the power n. So we take 31 square common, we get 961. We get multiple of NC2 plus NC3 times 31 up to 31 to the power n minus 2, which is divisible by n greater than or equal to 2. When n is equal to 1, expression becomes 0 and hence divisible by 961. And thus the given expression is divisible by 961 for all n in set of positive numbers. Next three problems are similar. We have this to be divisible by 64. 2 to the power 5n plus 5 minus 31 minus 32 is to be divisible by 961. And 3 to the power 21 minus 32 n square plus 24n minus 1 is divisible by 512. So all these problems are similar in nature. And you can see 3 to the power n plus 2 has been written as 9 times 1 plus 8 to the power n and then subtracted. So we see this becomes a multiple of 64. This we extract to the power 5 and it rewrite as 32 times 1 plus 31 to the power n. And this one we take out 3 square common and we write as 1 plus 8 to the power n. And thus we see all these are divisible by their respective quotient or divisors. Question 58 says that if 3 consecutive quotients in the expansion of 1 plus x to the power n be 165, 330 and 462, find n and r. So we let 3 consecutive quotients are r plus 1 and r plus 2. So NCR minus 1 is equal to 165, that is n factorial upon r minus 1 factorial times n minus r plus 1 factorial is equal to 165. NCR is equal to 330, that is n factorial by r factorial times n minus 1 factorial is equal to 330 and NCR plus 1 is equal to 462. We divide first two, we get r upon n minus r plus 1 is equal to 1 upon 2, that is 3r is equal to n plus 1. From the last two, we again divide, we get r plus 1 upon n minus r is equal to 5 upon 7, set all r is equal to 5 n minus 7. We have two equations, two unknowns, we substitute, we get n is equal to 11, r is equal to 4. So position of Questions are 4th, 5th, and 6th respectively. Question 59 says that if A1, A2, A3, and A4 be any four consecutive questions in the expansion of 1 plus x to the power n, prove that A1 upon A1 plus A2 plus A3 upon A3 plus A4 is equal to 2A2 upon A2 plus A3. So we let the questions be Rh, R plus 1h, R plus 2h, R plus 3h term of the expansion. So we have A1 is equal to MCR minus 1, A2 is equal to MCR, A3 is equal to MCR plus 1, and A4 is equal to MCR plus 2. Now A2 upon A1 is equal to n minus R plus 1 upon R. So A1 plus A2 by A1 is equal to n plus 1 by R. That is A1 upon A1 plus A2 is equal to R upon n plus 1. Similarly, A2 upon A2 plus A3 is equal to R plus 1 upon n plus 1, and A3 upon A3 plus A4 is equal to R plus 2 upon n plus 1. So substituting the values, we see that the given expression is satisfied. Question 60 says that if second, third, and fourth terms in the expansion of x plus y to the power n be 240, 720, and 1080 respectively, find x, y, and n. So we don't let second term is MC1, x to the power n minus 1, y is equal to 240. Third term is MC2, x to the power n minus 2, y square is equal to 720. And fourth term is MC3, x to the power n minus 3, y cube is equal to 1080. From first two, we have 240 upon 720 is equal to 2 upon n minus 1 times 6 upon y. From last two, we have 720 upon 1080 is equal to 3 upon n minus 2 into x upon y. We solve these two, we get 1 upon 2 is equal to 2 times n minus 2 upon 3 times n minus 1, that is n is equal to 5. So y is equal to 3x plus 3x by 2, and we substitute this 240 is equal to MC1 x to the power n minus 1 y. We get x to the power 5 is equal to 32, so x is equal to 2 and y is equal to 3. And with this, we come to the end of question number 60. Now I will show you my books. So you can come to my website ashtavarkar.org. You can download algebra, trigonometry, and coordinate geometry books from second, third, and fourth links. Note that date will not be there. So when you download, you add the date and you add this date, which is given here. I cannot put the date because that will make all existing links invalid. Also, after 15 or 30 days, you come back and check whether your PDF has been updated. And if it has been updated, you download again and changing the date. Note that there are lots of typing mistakes, so be careful when you are reading this. Also, if you want to ask questions to me, you can come to this web application, which I have developed for you. So you can come and ask questions here. There are tags here. The tags are algebra, calculus, coordinate geometry, geometry, probability, and trigonometry and mathematics. You use these tags to ask your questions. So you need to create an account so you can register here and then you log in. After that, you'll be sent a confirmation email when you register. So once you do that, you click the confirmation email and your email will be verified, and then you can log in here and ask questions. So with this, I will end this video here. I hope that you are finding this playlist useful and informative. So thanks a lot for watching the video, and we will meet again tomorrow with 10 more problems on binomial expansion. So once again, thanks a lot for watching the video. Keep learning, stay curious, and most importantly, enjoy.